In this video, we'll be using our sum and difference identities. If you've not already done so, press pause to copy these identities into your notes. When you're ready to continue, press play. And the example that we'll be doing is to find the exact value of the expression tangent 13 pi over 12. Now this is not an acute angle, so we need to find an equivalent acute angle before we get started on this. So 13 pi over 12, 12 pi over 12 is a semicircle, and so this is the acute reference angle. This is 1 pi over 12. And we know that tangent in quadrant 3 is equivalent to a tangent of an angle in quadrant 1. So we want to use the equivalent tangent pi over 12. Now we can write this as 1 pi over 12. That might help a little bit. Okay. Now I need to use my special angles because we're wanting an exact value. So remember, our special angles are 30 and 45 and 60. 30 is pi over 6. 45 is pi over 4. And 60 is pi over 3. Now, since this is in twelfths, let's go ahead and get a common denominator. This is 2 pi over 12. Multiply here by 3. So this one is 3 pi over 12. And multiply here by 4. And so this is 4 pi over 12. So to get 1 pi over 12, looks like I can subtract the 60 and the 45, or the 45 and the 30, it doesn't matter. So let's do 4 pi over 12 minus 3 pi over 12. So we'll do, this is our 60 and our 45. So we can write this as tangent of 4 pi over 12 minus 3 pi over 12. Right. We'll need a reference triangle for 4 pi over 12 is a 60, so across from that is the root 3. This is 4 pi over 12. And then for the 3 pi over 12, that's our 45. And we always use 1 root 2. And that's our 3 pi over 12. Okay, so for the tangent of a difference, that's showing right up here. If you haven't memorized it already, what we want is the tangent of our first angle, which is 4 pi over 12. Subtract the tangent of our second angle, which is 3 pi over 12. And then divided by 1 plus the product of those two. Tangent 4 pi over 12, tangent 3 pi over 12. Now tangent is defined as opposite over adjacent. So for the 4 pi over 12, the tangent is root 3 over 1, which is just root 3. Subtract. And then the tangent of 3 pi over 12, again opposite over adjacent, so that's 1. And then this is just 1 plus the product of these two tangents, so root 3 times 1. We didn't need to write this one here, but the others we do. So my answer just is root 3 minus 1 over 1 plus root 3. Now, most books require that you rationalize the denominator. When you have a sum like this, and you have a radical in one of the terms, you need to multiply top and bottom by the conjugate. Now, the conjugate of 1 plus root 3 is 1 minus root 3. So let's, I'm going to go this way here. Let's FOIL this out. Root 3 times 1 is root 3. And then the outer product is root 3 times a negative root 3. So that's just 3. Well, negative 3. And then the inner product is negative 1 times 1. So that's negative 1. And then the last one's negative 1 times negative root 3 is a positive root 3. In the bottom, 1 times 1 is 1. And then our outer product is negative root 3. And our inner product is positive root 3. So those cancel off. And then the last terms, positive root 3 times a negative root 3, will give me a negative 3. Now we'll just do the arithmetic here, and we should be good to go. I have negative 4, and then plus 2 radical 3 over, and this is a negative 2. Okay, we still can simplify. We still can simplify because all of these terms have a factor of 2. So let's split this up this way. Negative 4 divided by negative 2 is 2. And then 2 root 3 divided by a negative 2 is a negative radical 3. And that's our answer.